Welcome friends. Now we are entering into the fourth week of this course on manufacturing strategy. In last complete week we discussed about the concept of order winners and qualifiers. We discussed particularly about three very important order winners and qualifiers: price, delivery reliability and delivery speed. We discussed that speed is becoming a very important criteria of customers' preference across the markets nowadays. The development of e-commerce, and not only e-commerce but how to deliver product at a faster rate, is becoming a key criteria for the success of many of the businesses. And that is one particular reason. If I take you to the history of company known as Dell, that they changed their business model to make faster deliveries to their customers, because on one side customers are requiring variety, customers require products of high quality, customers require product at lowest possible cost, but nowadays customers also require products at a faster rate. So, delivery speed is a new addition in the list of various order winners and qualifiers, because as we discussed in one of the session that current markets are characterized by rapid change, and therefore we want products at a faster rate. Otherwise, by tomorrow it is quite possible that we may not require that product, because a new product may come into the market. So, therefore, it is not only from the point of view of the customer, but it is in the interest of organizations also to make their products available quickly to the customer. Otherwise, customer may change its mind, and if customer changes the mind, your product will not be sold, and that it is just going to be the losses for the organization. So, we discussed these three important qualifiers and winners: price, delivery reliability and delivery speed. When we were discussing about delivery reliability and delivery speed, we were focusing continuously on this particular aspect, that how to reduce the lead time. Lead time, when I say lead time, is process plus material lead time. That is my total operation lead time. So, how to reduce this operation lead time so that I can meet the expectations of my customer? That was the point we initiated in our previous session, and we discussed that there are certain short term strategies where we can do some kind of either overtime to our workers, or we can outsource some of the requirement from some other parties to fulfill the customer's requirement. So, all these are the short term measures, but three important things which are required for permanent solution of this reducing the lead time. One is related to capacity, the second is related to scheduling, and third is related to inventory, and inventory particularly related to work in process and finished. So, these are the three important areas around which we need to make some kind of decisions, so that we can see that how to reduce the lead times. We need to see, do we need to enhance the capacity so that we can fulfill the customer requirements from in-house activities, or our scheduling activities are not appropriate, we are not able to fulfill the requirement of our key account holders, and therefore customer dissatisfaction may increase, or our inventory system is too much based on JIT and we are not able to get proper material from our vendors. So, these are three important areas. Now, for solving these problems permanently, you can have different types of design of your system. Now, the different types of designs which are possible, the one design is design to order, and you see I have arranged these different concepts: design to order, then engineer to order, then make to order, then assemble to order, and then make to stock, in a way that the lead time is reducing from design to order to make to stock. As you are going from position number 1 to position number 5, the operation lead time is reducing. When we are designing to order, in that particular case, we receive the order from the customer, and then as per the requirement of the customer, we design the complete solution. We design, we produce, we implement, we take the after corrections, and all those things are the part of design to order. So, you can understand that it has a very long lead time, because designing of the product starts only after the order has come, only after you have understood the requirements of the customer. So, you go for a very high level of customization. So, it is very high level of customization, and therefore, customer is ready to wait, because you are designing a product for a particular customer. So, maybe if I talk like very heavy industrial goods, if I am looking for a turbine, so probably that will come under design to order kind of thing, because what type of head I am going to provide, what type of tail is available, and depend what type of power I need to generate. On the basis of that, the product will be designed, and once the product will be designed, then it will go for the production. So, in some industrial cases where the products are of very high unit value, we go for design to order, but in this particular case your lead time is also sufficiently long. The second is engineer to order. Here a primary design is available to you, and that design is more or less a standard design, primary or standard design available, but you are not using this design for making the final products. Once the order comes, you do some kind of minor changes, so that minor engineering changes, like if I need to do refrigeration of a hall. So, I know that how to develop a refrigeration system for this hall, but depending upon what type of capacity of that hall is, I will add whether there has to be 4 ventilators or 5 ventilators. Those type of things I will decide only on the basis of knowing the specification of the hall. So, these are the examples where design is already available, but the implementation of design will take place only after the order comes. That type of activity is known as engineer to order. Since we are not doing the initial designing of the product, so we can save some of the lead time, some of the time in delivering the product. So, therefore, it comes at the number 2. Then make to order. Here we do not have anything to design, anything to engineer. Everything is very much available to us. We have different types of products which are complete in their design, in their engineering aspect, but we are not producing those products. We are not producing those products, we are only waiting for orders. Like for an example, in India, in last few years, a company known as Hindustan Motors, which was very popular once upon a time for making a very popular car known as Ambassador. But the Ambassador cars in last few years were made against orders. So, there was no new design, there was no new engineering in those cars, but they followed a system of make to order. So, if you require, if you are a government servant, if you are a government office, you require ambassador car. So, you place order to Hindustan Motors and against your order car is delivered. So, since there is no designing, no engineering, so your lead time further reduces, but it is still considerable because the whole manufacturing processing lead time is still involved. So, that is the third type of strategy, make to order. Many companies in order to reduce the risk at the retailer's end follow the concept of make to order. Once order come, then only the products will be manufactured. Then another possibility is assemble to order. In assemble to order, what happens, we keep modular products, modular components you can say. Modular components are available with us, and as order comes, we assemble those modular components to make the final product. So, in some cases when we are not exactly making every component in a new way, we go for assemble to order. Companies like IKEA, a very good example for this assemble to order. They keep various components of their furnitures in the modular form, and as order comes, they assemble those modular components to give the final shape of the product. So, modularity is the key feature of assemble to order type of organizations. And then finally, you have this policy of make to stock, where you are keeping products readily available in your stock. You are keeping products ready off the shelf. Customer goes and purchases it without waiting for even a minute. So, that is where you have the shortest lead time. It is not simply the short, but it is the shortest lead time, that you are not spending, you are not waiting to procure the product. You immediately, as soon as you want the product, you procure it because the product is readily available in the stock. So, if you see, if depending upon what type of product you are in, you can follow from design to order, to engineer to order, to make to order, assemble to order, or make to stock type of production strategy, so that your lead time can reduce from long lead times to shortest lead time. If you are making turbines, so either you will go for design to order or engineer to order. So, if even in case of turbine, if you are into a small hydro, you can go for engineer to order, but if you are going for large scale hydropower projects, this is design to order. Make to order, the example like Ambassador is good enough to understand that how companies try to reduce their inventory cost by going for make to order, though they are not giving you any kind of novelty, but just to reduce the inventory cost, they follow the approach of make to order. Assemble to order, again to reduce the space at the retailer's end, they go for modularity, and IKEA is a very good example. Make to stock, to further reduce your lead time, and in most of the fast moving consumer goods FMCGs, you will see that we follow a principle of make to stock. All our cosmetic products, all our eateries are readily available in the stock, and you go to the shop and purchase it, because you have so much temptation to shift from one product to another product. If it is not readily available, you will purchase some alternative. So, therefore, you as a manufacturer, we need to follow the idea of make to stock in case of FMCGs. So, you can also see that based on our purchase involvement, our purchase involvement is low. you make another column, that is purchase involvement, and purchase involvement increases as we move from 5 to 1. I am not deeply involved in make to stock type of product. Whichever is conveniently available to me, I purchase those products. But in case of make to order, engineer to order, design to order, these products, my involvement is high, because they are high unit value products. So, you can also see that these are purchase involvement, then you can also add unit value. So, these are high unit value products, and make to stock type of products are low unit value products. So, your stocking cost is not very high, your inventory holding cost is not very high, because unit value of items towards 4 and 5 is low, and items which are at 1 and 2 or even at 3, their holding cost is high. So, you can do this comparison on variety of ways, and you will see that how design to order to make to stock can offer you different types of advantages. We discussed it primarily for the sake of lead time, that how to reduce your lead time, and in that case you can follow these alternatives, and depending upon the type of product you are serving, you can choose one type of initial positions for your organization. After that, the fourth important order winner and qualifier is quality. Quality is a very important aspect of production operations management. We in our course in the beginning discussed 3 letters QCD: quality, cost and delivery. So, you already know that Q is a very important place in our discussions. So, now we are going to start the discussions of order winner and qualifier, particularly quality in our mind. Now, when we talk of quality, there are 2 meanings of quality. 2 meanings of quality, one is from the customer's point of view, and another is from the manufacturer's point of view. Now, when we talk of quality from the customer's point of view, fitness for use, the product should be able to fulfill the intended purpose. That is the meaning of quality of product from the customer's point of view. But from the manufacturer's point of view, the meaning of quality is to produce products as per the specifications, as per the design, as per the dimensions. That is the meaning of quality from the manufacturer's point of view. Therefore, in our discussion here, we are talking quality conformance, because we are discussing this quality from the point of view of the manufacturer. But the discussion of quality will remain incomplete if we do not add the customer's dimension into it, and customer's dimension says that fitness for use, that product should be able to fulfill, product should be able to deliver the function for which I am purchasing this product. If I am purchasing this whiteboard for writing, for making my teaching more effective, and if I am not able to do that effective teaching because I am not able to use this board properly, then it is not a quality product. If any product you name, I have mobile phones, I have spectacles, I have watches, I have shoes, I have car, scooter, so many products I use, but all these products I use for some purpose. I use these products to make my life more comfortable, but if I am not able to achieve those objectives, it means it is not a quality product. I wear shoes so that I feel comfortable and I look smart also, but if I wear a shoes of some soldier which are meant to provide safety to my legs, that is not going to fit, that is not going to fulfill my purpose, and therefore, those shoes may be a very quality shoes for a soldier, but not a quality shoes for me. So, depending upon user to user, your definition of quality, your meaning of quality will change, and therefore, we say from the customer's point of view, when we talk of fitness for use, quality becomes a relative term. It is a relative term. Fulfilling the specifications, fulfilling the conformance is a more like a standard thing, but fitness for use is more like a relative term. So, we need to understand the very first thing, that quality can be understood from both these point, customer's point and the manufacturer's point. Now, when we go further into the detail of quality, so there are different types of dimensions of quality, and let us discuss quickly these dimensions of quality, that what do we mean by different aspects of quality, because it is such a common word quality that we all have some meaning associated with the quality, and let us see that how you can define quality using these different dimensions. Now, one of the dimension of quality is performance. The performance means the primary characteristic of a product, primary characteristic of a product, that is the performance. So, if I am purchasing a laser printer, if I am purchasing a laser printer, and if that laser printer is printing 15 pages per minute, that becomes the performance, that it is printing 15 pages per minute. You are purchasing a laser printer, that laser printer is printing 20 pages per minute. So, that is the performance of your laser printer. Some other heavy duty laser printer is there, it may print 30 pages per minute. So, that is the performance of that laser printer. So, the primary characteristic of the product is known as performance. But nowadays we are not satisfied just by primary performance, we need add-on features also. So, that is the secondary characteristics, whether it has automated double side printing or not. If my laser printer has automated double side printing, that is a feature. If it knows that, it is do not having any additional features. So, double side printing can be one feature. Then similarly, in other product categories, you can think of that what is the performance and what is the feature. Then the third important dimension is reliability. Now, reliability means the probability of a product malfunctioning within a given period. Now, you know that this printer has a life of 2 years. So, whether this printer is working without any kind of trouble for 2 years or not, if it can fail within 1 year, within 6 years, so it has low reliability. But if it fails around 1 year 10th month, then it means high reliability, and if it fails after 2 years, it has very good reliability. So, you have a relative spectrum of reliability depending upon when it is failing on the basis of its given life. Then aesthetics, what is the outer look of your product, how the product finally looks. Some of my friends few days back make a 3D printer. Now, that 3D printer was made inside our lab. So, it was looking like they have various components lying here and there, though it was giving much better output than the purchased 3D printer. But because the final shape was not looking appropriate, it was not a commercial entity for that purpose. So, you need to see the final shape, that what is the look of that product, that is also a very important aspect of quality. You go to different types of restaurants, different types of saloons because of their aesthetics many a time, because their look is very good. Then another important dimension of quality is durability. Now, durability of a product is a measure of product's life in terms of both technical and economical dimensions, that how long a product can work. So, you need to understand the difference between reliability and durability. Now, in case of reliability, that the chances of failure within the life of a product, that how many times product will fail, and durability is how long a product can work. Though the life specified life of the product is 2 years, but sometime products may work for 3 years, 4 years, 5 years also. The life of the product is 2 years, but sometime you may need to change product after 1 year, because it is giving so many faults repeatedly that you find that it is hampering your work. So, it is better to change the product. So, durability is the measurement of total life of the product. Then conformance. Now, conformance is very simple, we have already discussed this aspect, that whether our product is meeting the specifications or not. So, that is the conformance. Then serviceability or maintainability. Serviceability is also known as maintainability. If your product fails, maybe under planned maintenance or maybe under breakdown maintenance, how easy it to recover, how easy it to maintain, that is the aspect of serviceability. We want products should be repaired within no time. It should not require very high level of skills to repair those products. So, that is the aspect of serviceability, that you should be able to make, or you should be able to rerun your products, your equipments easily, that is the serviceability aspects. And then finally, the perceived quality. The perceived quality, that how a customer view your product. Despite all these characteristics, perceived quality is a separate type of dimension. You may be very good in all these initial dimensions, but if a customer is not looking you as a favorable product, these dimensions will lose the meaning. So, you need to create an aura, so that customer also sees you from the positive mindset, and probably the marketing function can play some role in improving your perceived quality. If you go to a class of branding, they will teach you that how to improve the perceived quality. So, there need to be a very strong communication from the organization and to the customer, so that perceived quality can be improved. And if you are having very good features, very good performance, reliability, but customer feels no, this product is not good, this product is not up to the mark. So, despite having all these phenomena, all these dimensions, your product will not sell. So, perceived quality, though it is mentioned in the last, but it is one of the very important phenomena in using quality as order winner and qualifier, that you need to have a very high degree of perceived quality. So, quality is understood in these 8 dimensions. Now, it is important to understand that all the products may not have all these 8 dimensions of quality. Some of the products may have many dimensions, some of the products may have few dimensions. So, depending upon what type of product you are, if you are talking of an industrial product, so maybe aesthetics will not play very important role, but when you are talking of a product which is to be used by some individual customer, then aesthetics may play a very important role. So, just to give this example, you will see that in physical products different types of dimensions will be applicable, and in service products different types of dimensions will be applicable. So, we come to end of today's session with this discussion of different dimensions of quality. In our next session we will discuss few more order winners and qualifiers. Thank you very much.